All right, welcome to the channel. This is the first in my routing protocol tutorial video series. This is where I explain just various things about routing. This video in particular is about OSPF, just the basics. So we're going to cover establishing an adjacency and specifically just these basic items here that are in this OSPF config. This is down in the description if you want to look at it. Also, if you want a video later on how to set up GNS3 so that you can do this yourself, I will just let me know in the comments below, and I will go ahead and make that video. All right, so moving forward, I've already preloaded both routers with the full config. So we're just going to run a couple basic commands to figure out, just to look at and confirm the config. So we're going to look at this show IP int brief command on both routers just to verify that the interfaces are all in there with the correct IPs and they're all up. So looks like they are, and you want to see status and protocol both up. So when someone's asking you about an interface, if it's up, that's what you're looking for, is up here and up there. Okay, so the interface router 1 and router 2 are connected on is gig interface 00. Both of them are using that same interface number. Also, just a side note, you'll see this in probably all my tutorials. I like to use IPs on the peering interfaces between sites that is outside of the typical prefix for that site. So router 1 is the 10.0.0.0/16 IP range. So all IPs will be within the 10.0 range. And then router 2 is within the 10.1.0.0/16 IP range. That's the prefix that it's in, and all IPs will be within there. All right, so let's go ahead and just verify that the adjacency is up. And we do that. Here's the command that's also in the description. Show IP OSPF neighbor. I've abbreviated these things. Show can be abbreviated. You can take the O off of that and it's just SH. I prefer show. That's just a preference. Doesn't matter. All right, so we're going to look at both of these, and yep, both are up in a full state, meaning they are in full exchange. So they're in the state that you want to see routers in when they're peering with each other in OSPF. So router 1 is peering with router 2, and router 2 looks to be the DR, designated router. And router 1 looks to be the backup DR, the backup designated router. What that means is the advertisements for the rest of, if you were to add nodes to this, all the nodes would come back to the DR to get all of the route advertisements. And then the backup DR, if the main DR goes down, backup DR takes over. So that's just so that we're not flooding the network with OSPF packets. Also, side note, OSPF uses multicast to be able to establish its adjacency. So if you're ever troubleshooting something in an OSPF, adjacency keeps going up and down, it could be that multicast is failing on the peer connection. I had that with a vendor, and it took a while to troubleshoot, and then it took a while to convince them of that. So anyway, just a side note about that. So let's look at the route table here. So we're going to do a show IP route, and then just we'll just look at the full route table and show IP route. All right, so if we want to clean this up and not see the connected or local, we can just do a section O. You could do include, but sometimes the include will leave out some things. And anyway, I'll have a video on what these commands do later. But at any rate, so you can see router 1 knows about all 4 of the networks that are on router 2. and router 2 knows about the ones from router 1. All right, so let's get into this router config here. So router OSPF 100, both of these are set up with that same OSPF 100 command, but this number is locally significant. So router 2 could be router OSPF 101, and router 1 wouldn't care about that because it's only locally significant. Also, here we go, router ID. I set this to be loopback 101's IP address. You can set this to whatever. If you don't have a router ID specified, it'll choose the highest loopback IP. So in this case, it would be loopback 100, which has the highest IP. All right, so log-adjacency-changes detail. This is exactly what it does, exactly what it says there. It logs adjacency changes and the details of it. So this comes in handy if you have a logging server that can send alerts based on these. So if it sees these logs come in, it will alert you on that. So that's nice if you have something set up external to this. Sorry, I've been doing a lot of takes for this video, and so my mouth is really dry. So moving on, redistribute connected. So if you have routes from a different protocol that you want to use in another protocol, you need to redistribute those. So connected routes, those are the routes that are connected to this router. So loopbacks, physical interfaces, and virtual interfaces. So like if you have a VLAN interface. And all right, so that's connected. Redistributing connected routes, setting it as a metric type 1. I prefer type 1. By default, type 2 is what Cisco has. I prefer type 1 because the metric increments as it goes to the various hops through the network, which comes in handy when doing route design with multiple paths, path redundancy. Subnets. This is very important. If you don't have that, then it'll only route classful subnets, and 99% of the time you don't want to do classful. So include subnets there. All right, passive interface. By default, all interfaces in Cisco routers will advertise and accept OSPF advertisements. I don't like that, so I passive all of them out and set that as the default, and then I no passive just the interfaces that I want OSPF to come in on. Then, so we set network, and this is for if you want, so your interfaces like gig GI00 has an IP address within this network, and without this, it won't accept OSPF. It won't come up. This is a wildcard mask. So it's opposite of what the masks are that you've probably seen elsewhere. So where you would see 255, 255, 2550, this is the opposite. So 000, 255, wherever you want. And this just means it's a /24 and that it's expecting packets on the interfaces that have IPs within this range. And we're setting that in area 0. All right, guys, so I tried to make that quick. Hopefully that helps a little bit. We'll get into more in-depth later. Right now I have a really weird setup with my microphone, and I'm limited to 10 minutes on my record. So we're approaching that right now. Thanks for watching. If you have questions, leave them in the comments section. I'll do my best to respond to them, and I'll have more in-depth videos in the future. So thank you very much, and have a nice day.